Welcome to this mental math lesson. Today we'll be talking about trailing zeros as a multiplication and division strategy. Here we go. The first thing I would like you to do is compare the numbers 7 and 700. How are they the same and how are they different? They are the same because they both have a digit 7. In the number 7, 7 is in the ones position. In the number 700, 7 is in the hundreds position. So they have the same digits, but they're in different positions. And 700 also has 2 zeros as digits. Next, compare the factors and the products in the following equations. So remember, factors, those are the numbers that are being multiplied. Products are the answers to the multiplication questions. So take a minute to look at the factors and the products of each. What is the same? What is different? Okay, in the first question, our factors are 2 and 7, and our product is 14. In our second question, our factors are 2 and 700, and our product is 1400. So again, we have some similarity in the digits, but some difference in the place value of those digits. And the place value is different in the second question because we have some extra zeros as digits. 7 becomes 700. And our answer of 14 in the first question becomes 1400. So maybe you're starting to see a pattern here. Let's keep going. Okay, let's start with the question 3 times 2. We know that is 6. I'm going to write out the products for these next few questions, and I want you to see if you can come up with a pattern that will help you relate this initial question to the answers below. Okay, we can see some patterns here. We can see that all of our questions have a 3 and a 2 for digits. The 3 and the 2 are in different place value positions, but we always have a 3 and a 2 and some zeros. And our answers always have a 6 followed by some zeros. So maybe you've noticed a pattern here. Test your theory by finding the answer to 5,000 times 3,000. So we know that there's a 5 and a 3 being multiplied, so probably there's going to be a 15 in our answer. But how do we know how many zeros there should be? So the 5 and the 3 do multiply to give us 15. And because this is not just 5 ones, this is 5 thousands, the answer needs to be at least 1,000 times bigger. But this is not just a 3, it's a 3,000. So it needs to be another 1,000 times bigger. So we can get the non-zero part of our answer from the non-zero numbers in the question, and then to figure out how many zeros there are in the answer, we can look at how many zeros there are in the question. So could you write a general rule that would help another student easily find the product of numbers with trailing zeros? So the trailing zeros are just these. They're all of the zeros that follow any non-zero number. As we saw before, we can look at the non-zero parts of the question, 5 and 7. Since 5 times 7 is 35, we know that those digits are going to be the beginning of our answer, the beginning of the product. Now to finish this product, we know we need to account for all of these trailing zeros, because that's not a 5, it's a 5,000. So the 1, 2, 3 zeros that push the 5 to the thousands position, and then the 4, 5, 6 more zeros that push the 7 to the thousands position, they need to be in the product. So I'm going to put all 6 of those zeros in my final product. Done. Let's look at 2,000 times 4,000. I know my 2 and my 4 are giving me an 8 when I multiply them, but it's not 2 ones, it's 2 thousands. And it's not 4 ones, it's 4 thousands. So those 6 zeros from the question are going to go into the answer. Easy peasy. Pause the video and give these a try, and then come on back and check your answers. Okay, here's what your answers should look like. 400 times 7,000, that gives you 2,800,000. 2,000 times 80 gives you 160,000. So the 16 with 4 zeros pasted after. This third one could have been a little tricky. Let's look at it together. 500 times 40,000. We know 5 times 4 is 20. So my answer needs to begin with 20. And then I need to paste on 6 more zeros. My answer actually ends up having 7 zeros in it, but that's because one of the zeros belongs to the 20, so we don't count that as one of the trailing zeros. And then finally, 12,000 times 200 is going to give you 2,400,000. Okay, now let's look and see how trailing zeros affect division questions. Take a moment to compare the dividends, divisors, and quotients in these equations and see what patterns you can see. So every question starts with the digits 2 and a 4, and the divisor in each question contains a 6. Now 24 divided by 6 is 4, so all of the quotients contain a 4. But we have different numbers of trailing zeros in our questions here. So let's see if we can figure out a way to relate the trailing zeros from the questions to how many we need to have in the answer. In the first one, I don't have any trailing zeros on either side, so my answer is just 4. In 240 and in 60, they each have one trailing zero. Now, 6 goes into 24 4 times, and 60 goes into 240 also 4 times. So there's no trailing zeros to tack on. It's almost like we could eliminate the same number of zeros from both the dividend and the divisor. Let's look at the next one. 60 goes into 2,400 40 times. So there was a zero I needed to tack on there. And if I look and see, I can eliminate 1 zero from each side, but there's still an extra 0 there. And that is the one that gets tacked on in my answer. Let's practice this here. 18 divided by 6 is 3, so let's use that to help us with these answers. Okay, so we can see similar patterns here. 18 divided by 6 is 3, and those same digits are common in all of these questions. But we've got some zeros in there, so we need to figure out how to account for the zeros that are in the question side to the zeros that are on the answer side. So in 18 divided by 6, we are asking how many 6's are in 18? There are 3. In the next question, we're asking how many 60's are in 180? Still 3. And you'll notice they each have a 0. So if you kind of eliminate 1 0 from each side, you're back to the question 18 divided by 6, because those are equivalent questions. Again, how many 600's are in 1800? 3. I can eliminate 2 zeros from each side and bring it back to 18 divided by 6 because they are equivalent questions. 18,000 divided by 6,000, how many times does 6,000 go into 18,000? 3. I have 3 zeros on each side that I can get rid of because it's an equivalent question to 18 divided by 6. Okay, in 180 divided by 6, 6 can go into 180 quite a few times, 30 actually. So we start with the 18 divided by 6, and that's what gives us our 3. Because there is an extra 0, it's not 18 ones, it's 18 tens, that 0 goes on to our answer. There were no zeros that we could eliminate on both sides, so we just had to keep them. Again, I have an 18 divided by 6, so I still have a 3 in my answer. And this time it's 1800, so those 2 zeros are going to get tacked on in my answer too. And then I have 18,000 divided by 6. I still have a 3 in my answer, but because it's 18,000, I'm going to tack on those 3 zeros. Okay, let's get to these bottom three questions where there are zeros on both sides. We still have an 18 divided by 6, so we're still going to have a 3 in our answer. I have some zeros on both sides, so I can eliminate zeros as long as it's the same number of zeros on each side of that division sign. Now I still have one extra one, so that's why I tacked on one extra 0 here. 18 divided by 6, that gives me my 3, and I can eliminate 1 0 from each side. The 2 extra trailing zeros get tacked on. And then in 180,000 divided by 60, I still start with my 3 for an answer. I can eliminate 1 0 from each side, and that leaves me with 3 extras to tack on. Okay, so knowing this pattern, do you think you could find the answer to this question? Pause the video and give it a try. Come on back. Okay, I see a 25 at the beginning of this number, 25 million, and I see a 5 at the beginning of 5,000, or 500, sorry. So I know that 25 divided by 5 is 5. Now let's figure out how many zeros I need to include in my answer. I have 2 zeros that I can eliminate from both sides, but that leaves me with 4 extra zeros in my dividend, and they go in my answer. Can you write a general rule that would help another student easily find the quotient of numbers with trailing zeros? Pause for a moment and see if you can write out a rule or strategy to help with this type of question. Okay, so for the first one, 56,000 divided by 7,000. First, we're going to look at the non-zero numbers. So 56 divided by 7 is 8. So we still know we're going to have an 8 in there. So as a general rule, we could say divide the non-zero numbers. And then we can eliminate any extra zeros as long as we're eliminating the same number on each side. And since I was able to eliminate all extra zeros, I don't have to put any zeros in my answer because 7,000 goes into 56,000 the same number of times that 7 goes into 56. They are equivalent questions. 28 divided by 4 is a 7, so I know my answer will start with a 7. Now I can eliminate 2 zeros from each side, and I have 2 trailing zeros remaining, so they go in my answer, 700. Pause the video, give these a try, and come on back. Okay, here are your answers. Let's go over the last one together because that might have been the tricky one. So at first you might have thought, well, 2 divided by 5, I can't do that. 2 does not divide by 5 evenly. But if you extend over to include a 0 with the 2, now it's 20. So that's what you'll need to do if you find yourself in that situation. This is 20 divided by 5, which gives you 4. And then you can eliminate any extra zeros you have, and you're left with 2 trailing zeros. Remember, the 0 that's part of the 20, that's not a trailing 0. That's part of what you divided. So 400 is your final answer. Okay, now it's time for some extra practice. Hop on IXL. In the grade 4 module, you can do these lessons. In the grade 5 module, you can try these lessons. And then when you feel ready, you can go to your activity booklet and try this work page. I'll see you in the next lesson.